Let's take a look at the most powerful tool that we have at our disposal, that of mathematical manipulation. The reason it's important for us has to do with the fact that the SAT will really test us, and knowledge of manipulation will come up at a vast majority of questions that you'll be dealing with. So to start off, let's take a look at the following expression or equation. X plus 3 equals 1 plus 4. Here we have an equality sign and two pieces on each side of it. To the left we have x plus 3 and to the right we have 1 plus 4. X is an unknown and our goal is to define it. So in order for us to know what this mysterious x is, we need to isolate it on one of the two sides of the equality sign. We'll keep it on the left side, but before we accomplish this, we need to do something with this plus 3 piece. To do so, we will subtract 3 from the left side, and what we get is x plus 3 minus 3. The only problem with this is that now x plus 3 minus 3 does not equal 1 plus 4. So to do justice, we'll subtract 3 from the right side as well, in which case we'll restore the equality of this expression. Let's take a look at what happens here. X plus 3 minus 3 now equals 1 plus 4 minus 3. As a result, we have isolated x since plus 3 and minus 3 equals 0. So x plus 0 equals x. And on the right side, we have 1 plus 4 minus 3, which equals 2. And we have solved for this unknown x, and our answer is 2. Take a look at the next example. It is very similar to the one that we performed, and our approach will not change much, but there will be a slight difference of how we go about it. The general concept is the same. We're trying to isolate x, and we're trying to neutralize this operation that is on the side of x. In this case, however, instead of addition, we're dealing with multiplication. And the opposite of multiplication is division. So to neutralize times 5 on the left side, we will divide by 5 both sides of the equation. What we get is x times 5 divided by 5 equals 1 plus 4 divided by 5. 5 divided by 5 equals 1. And so x times 1 equals 1 plus 4 divided by 5. X times 1 equals x. So we have achieved our goal of isolating x on one of the sides of the equation. And on the opposite side, what we get is 1 plus 4 equals 5, divided by 5 equals 1. Our result is x equals 1. So what is the difference between the two examples? Well, the difference is that in the first case, we were looking for the setup x plus 0 equals x. Whereas in the second case, we were looking for x times 1 equals x. Let's summarize. When given an unknown and asked to solve for it, we're using the following steps. First, we are trying to isolate this unknown on one of the sides of the equality sign. Second, to do so, we are reversing the operation that gets in the way. So in our examples, there were operations plus 3 and times 5 on the side of x. And we reversed them by subtracting 3 in the first case and dividing by 5 in the second. And finally, we need to maintain the equality principle, which means that we should mirror these operations of minus 3 and divided by 5 in our case, and do it applied on the opposite side, so the equality is maintained. Let's briefly apply the newly gained skill. So take a look at the 4 different setups. X minus 2 equals 5, x plus 2 equals 5, x times 2 equals 5, and x divided by 2 equals 5. These are 4 situations of main operations, which is subtraction, addition, multiplication, and division. In each case, we're trying to reverse this operation on the side of x. And in case of addition and subtraction, we're trying to neutralize and have a setup of x plus 0 equals x. And in case of multiplication and division, we're trying to set up x times 1 equals x. Despite all this, basically all you need to remember is that you need to use the opposite operation to the one that you're seeing. So in example 1, x minus 2 equals 5. The opposite of minus 2 is plus 2. But of course, we gotta do it on both sides of the equation, so the equation remains an equation. As a result, what we get is x minus 2 plus 2 equals 5 plus 2. On the left side, we have isolated x, because x minus 2 and plus 2 actually equals x. And on the right side, we have 7, x equals 7. In the second equation, x plus 2 equals 5. The opposite of plus 2 would be minus 2. And of course, we have to apply it to both sides. And as the final setup, we get isolated x on the left side equals 3. In example number 3, x times 2 equals 5. The opposite of multiplication is division. So we divide by 2 both sides. And our answer is 2.5. And in the final situation, x divided by 2 equals 5. The opposite of division is multiplication. When we multiply by 2 both sides of the equation, we get x equals 10.